Rosetta has successfully completed its first main thruster burn, an essential orbital correction maneuver that keeps the spacecraft on target for Comet 67P Churyumov-Gerasimenko. Members of the mission team monitored the burn in real time at the Rosetta control room at the European Space Operations Center in Darmstadt, Germany. The first of 3 major burns took place 500 million kilometers away on May the 21st. It used 218 kilograms of fuel and lasted 7 hours and 16 minutes, one of the longest thruster burns in ESA's history.
It's a whole mixed bag of feelings. I was very nervous for these maneuvers. I lost a few nights of sleep, I can tell.
2 more big thruster burns take place in June. These are a crucial part of the journey. Any mistakes, and instead of orbiting the comet, the spacecraft would fly right past.
So the next crucial stages is we need to get all the next burns to work so that we successfully reach the comet and stay with the comet. And then we'll start the initial characterization phase of the comet to better identify a landing site, and then to start the phase where we will prepare for the landing of the lander on the comet.
Studying gases from the comet nucleus along the way will help prepare for the Philae lander's unprecedented controlled landing on the comet in November. A collection of instruments is also measuring the properties of plasma generated by outgassing from the comet.
If you look at the nucleus of a comet, it's like a piece of coal. It's very dark and normally you wouldn't see it. It's only when you come closer to the sun, this comet activity, this material starts to become active and it's outgassing, and then the cometary tail is formed, and this is what we normally see in the sky.
Several of the spacecraft's 21 science instruments have already been busy during its 10-year journey, such as Rosetta's ALICE instrument, an ultraviolet imaging spectrometer from an international team across Europe and beyond. ALICE studied asteroid Steins and Lutetia, as well as the upper atmosphere of Mars and the Earth's magnetosphere. In June, it begins observing the comet.
ALICE won't be searching for anything that directly tells us about astrobiology or life, but it will be able to search for molecules like carbon monoxide and carbon dioxide that are carbon-bearing and that are very important to our understanding of the formation of atmospheres around the solar system and to the way that the comets themselves were formed.
Rosetta's instruments will work between burns during this orbital correction period. The priority is to gradually reduce the spacecraft's speed and continue the 2 large and 6 smaller thruster burns so that it is lined up to orbit the comet in August.